Hello, this is 10th video on my channel. Let's discuss other problem. Here is the question. Pause the video now and read the question and give it a try. Hope you have done this. Zepto is revamping its internal logistics network. The network is represented as directed chain. To optimize the network, in one operation you can break any edge in the tree, splitting it into two separate parts. The objective is to divide the original tree into a set of chains so that sum of squares of lengths of these chains is maximum. For example, if this is the given tree and this is the given array, so the parents of 1, 2 and 3 is 0, so it is 0 here, and similarly all. So from this we can construct a tree, and from this we can try to break some set of edges, and after finally we have to maximize the length of chains. For example, if we try to remove this and this edges, 4 directive chains are formed. The first one, second one, third and fourth. So first one is of length 3 because there are 3 edges, so it is 3 square, and other all 3 have 1 edge, so it is 1 square into 3, so it is 3. So the sum, if we remove the set of edges this and this and this, it is 12. Similarly, if we try to remove this and this, there are 3 chains formed. The first one is of length 3, the second one is of length 2, and the other is of 1. So it will be 3 square plus 2 square plus 1, it is 14. Similarly, if we try to break this and this edges, the answer will be 14 as well. So for this, the optimal answer is 14, and it is better to remove this edge and this, or this and this as well. So what is the directive chain? It is just like one node is attached to 2, the second one is attached to 3, and so on. Every node can have only at most 1 edge outgoing, so it is a directive chain. So from any node there can be at most 1 edge. So for example, based on 1, only 0, 1 should be there, or only 0, 2 should be there, or only 0, 3. So we have to keep 1 and we have to remove the other 2. So if we try to observe one thing, if we are at 0 and if we are trying to keep the edge 0 and 1 here, and how can we say that 0, 1 edge is already included for the other children? Because we have to check all the cases, because we can try to keep the 0, 1 edge, and we should say to all children 2, 3 that given the answers of your subtree, because I am already paired with 1, so 0, 2 and 0, 3 are already broken, so the answer will be the answers of 2 plus 3 plus and so on other children's plus the answer due to this. And similarly we have to try for 0, 2, 0, 3 and so on. So it is difficult to do this if we try to look from the point of perspective of parent, but if we try to look in the terms of child, for example, if this is the initial root and these are some of their children, and for example by some idea or trick we got that the best possible answer for first children is breaking the subtree into 2 chains of length x and z, and similarly for the other child the answer is a single directed chain of length y. And now from root it is better to check which is better. For example, if we are trying to make this one active and we are removing this one, the answer will be z square, because this is already paired and we cannot pair this one, and we are pairing x with 1, so x plus 1 whole square plus this one y square. And similarly, if we are trying to make this edge correct and if we are trying to break this edge, the answer will be y plus 1 whole square, and we are breaking this one, so it is a new chain x square plus z square. So by simplifying this we can get that all other terms are same except 2x here and 2y here. And if x is greater than y, obviously pairing the parent with higher one is better, because 2x is greater than 2y. So if for example if there is a parent node and there are many different children, and if we able to get the maximum chain which is possible from these edges, it is better to pair the parent node with that one. So the first observation is, if there is a parent node and there are many different child nodes, if the maximum length found so far here is x, and if it is here it is y and it is z, it is better to pair the parent node with the highest chain possible. But to find the answer, it is not simply possible, because for example based on this subtree, if we try to return the maximum length, that is x is the maximum directed chain found in my subtree. So if we only try to send this information, and similarly y here, we are forgetting some other chains which are in those subtrees. So in the subtree, if we are trying to return only x, which is the maximum length of directed chain possible with this child as root, but we are not storing any information that another chain is also there with a length z. So we have to return few things to the parent node instead of just the maximum length. So the first one is the maximum length of the directed chain possible from the present node. That is the first one. Here it is x and here it is y. And similarly, we need the other part, which is the already directed chain part, and we cannot pair them further now. And those are already broken. So we have to return this both information to the parents. So for example, let's take this one, and the maximum chain possible is this. So we will return 3 as the first one, because the maximum length with including this is 3 here, and the other parts are, as this is the highest one, we have already broken these 3 edges. So these are also the part of answer, but not included in the main directed chain. So the extra part here is 1 plus 1 plus 1, which is 3. So we will return 3 and 3 to the parent from this child node. So, and finally, if this is the parent node and there are 3 children for that, and the first one returns x0 z0, x1 z1 and x2 z2. And now we are trying to think, what will the parent return now? We got this information from the children and we are trying to return this to its parent. So as we discussed that this will pair with the maximum x possible, so the new length will be x plus 1, because the root is also included with it. So if we assume that x0 is the highest one, x0 is the highest one of all x of all the children, the new x will be 1 plus x0, because the root is also added with the main chain. And the extra part now is, we assumed that we are pairing with the highest one, so other edges are also broken. So these are also not useful from now, but contribute answer x square to the answer, because this is also directed length of chain x, but this is not going to form the further chain. So these are also included in z now. So this is x1 square and this is x2 square, and z0 z1 z2, which are already part of this. So if we receive this from the child, and these two are what returning to its parent. Let's check the code. We are initially inputting the number of nodes in the tree and inputting the vector of parents, and as it is a directed tree, we are adding only one edge, vj 2j, and finally we are inputting a pair, because we have to return 2 elements to that. It is better to take a pair instead of vector. So the function of 0 returns the x and z for the root, and answer is, and finally if the root has answer 2 comma 4, if the final root returns 2 comma 4 to main function, it means that we have found the maximum length 2 and there are some extra answer with 4. So the main answer will be 4 plus 4, 4 plus 2 square, because we found other chain and we did not add this contribution till now. So finally the answer will be p dot first whole square plus p dot second. So let's check the function, and initially the answer is 0, and if we found a root node, if we found a leaf node like this, there is no maximum length possible till now, and there is no any extra part as well. So we return 0 0 from the leaf nodes. So if we found the size of 0, return 0 0, and we are finding the x and z of parent, we are finding this, and int x is equal to 0 and z is equal to 0, and we are traversing through its children, and we are getting node length and wasted subpart for its child node. After returning this, we want 1 plus maximum x of all. So x is equal to max of x comma 1 plus node length, and similarly the z will be sum of squares of all. So initially it is difficult to find the maximum, so we can just try to add x square also in this, x square plus x1 square plus and so on, and similarly the sum of all z, and finally we can remove the maximum length whole square. So instead of just doing this, we can add the maximum square here and here, and this is by traversing the whole children we can directly maintain sum of x square and sum of z, and finally we can find the maximum one and remove it. So z plus is equal to x square and wasted from its child, and finally after the completion of whole loop we are finally removing this one. We have added this in the loop so far for all the children, and we are removing x minus 1 whole square because the new x formed is 1 plus z 1 plus maximum x naught. So we want x naught here to subtract it, so it will be x minus 1 whole square. So we are decrementing x minus 1 whole square from z, and finally returning x comma 0 to the main. So and finally here we are adding the length of main, the length of chain where the starting node is root and its square plus the wasted subpart of this. Hope you understand this. Drop a like and post in comments if you have any doubts. See you in the next video.